Hi, everybody, and welcome to the Kidney Coach YouTube channel. I am naturopath Fiona Chin, co-founder of Kidney Coach and Kaigenesis, a range of nutritional and herbal medicine designed to support people diagnosed with chronic kidney disease, whether you want to decrease your creatinine or bump up your eGFR. If you've listened to this podcast before, you will be recognizing my amazing guest over on the screen there, the amazing Dr. Alex Grinberg. Dr. Alex Grinberg is an integrative medicine practitioner. He works with rejuvenation, epigenetics, and longevity. He has a keen eye for oncology. He has got so many degrees. I don't know whether I'll go through all of them, as well as being a psychiatrist and doing a whole pile of amazing things in the biotech space, lots of startup companies overseeing clinical trials, but lifespan extension, longevity medicine, personalized anti-aging, nutritional optimization. He is your man. He is my go-to for all things peptides and all the new things coming down the pipeline there. He is a regular on our PepDoc Facebook page, which is a Facebook page private for doctors. And we often have Dr. Grinberg come on and he does the training for all the very well-versed doctors in there who are already very well-versed in peptides and training. So he's probably our mega brain on all things peptides. Dr. Grinberg, I always appreciate you coming on. I'm so excited today because we're going to be talking about mitochondrial peptides, but thank you for coming back and thank you for being you. And that beautiful background there of Lake Tahoe, it looks very relaxing and gorgeous where you are.
Thank you so very much, Fiona, for your presentation and for giving me a chance to talk to the broad auditorium and to share our ideas and hopefully to share the knowledge that may help people to improve their health, to utilize novel treatment strategies and interventions, and in many cases to get rid of the curse of incurable diseases.
Yes, exactly.
That's very important.
It really is.
And to add more about your presentation, about my background, actually, my background since first years in medical school was additional work in science of endocrinology, neuroendocrinology, deep studies of hypothalamus and interrelations between hypothalamus and other areas of brain pathways, and also neuroimmunology interface. And then upon graduating medical school, I was in PhD program in All Soviet Center in Immunology in the former Soviet Union, where I had honor to participate in clinical trials of Professor Kavinson peptides, mostly thymus-derived peptides, and working on different modalities of treatment, combining these peptides with plasmapheresis, with plasma exchange, with intravenous light and laser therapy as photomodulators. And then upon immigrating to United States over more than 30 years ago, after confirming my foreign medical licenses, I did residency training in psychiatry and started working along with my private practice, participated in the work of multiple biotech companies, participating in research on immunotherapeutics for neurodegenerative diseases. In fact, one of the companies that continues NIH-based research conducts and completes phase 1 safety trials of immunotherapeutics for Alzheimer and other neurodegenerative conditions in Adelaide in Australia. Sorry if I don't pronounce it correctly.
No, perfect.
And I work with other biotech companies that specialize in advanced stages of cancer treatments of metastatic cancers, whether small molecular or immunotherapeutics. And also involved in research of peptides, advanced research of peptides. And along with my private practice in San Francisco, California, I help patients internationally, providing recommendations and protocols for longevity or for advanced individualized treatments of clinical conditions where conventional medicine exhausted its potential, or people want to get more and get access to more advanced treatments. And I also consult physicians in a few centers around the world on the use applications of novel treatments and creating protocols for longevity and for treatment of clinical diseases, utilizing translational knowledge from advanced biotech industry and helping people to mitigate risks of using novel or experimental treatments as well. And a huge part of it is helping people with chronic kidney disease. It's a very significant problem that millions of people struggle around the world. Thank you so much, Fiona, for helping people to achieve good results and outcomes with these conditions. And thank you for getting me involved and sharing your ideas and your platform with me so we can do more together.
Yeah, well, that's a privilege. Like, your background is extensive and amazing, and just to be involved right from the, the stuff that you've been doing so long ago when, your original training with Cavison and, using photomodulation and peptides, and, you're 20 years ahead of the curve. So you've been in this space for such a long time, which is why I really revere you as the expert in this field, far more than, anyone else that I would see online. So I really do appreciate you sharing your knowledge with us, because you've been, doing it such a long time and really from the roots up, and really understand it from a functional point of view, being, with all your background in immunology and being a practitioner as well, and then being able to practice that one-to-one. And I know, for people that don't know, Dr. Grinberg and I talk off screen about novel peptides coming up and trialing them and using them, and there's a lots of stuff going on in the background of just how amazing this man is about getting stuff out there. So talk to me about all things. We're going to talk about mitochondrial peptides, but maybe what would be useful for people listening is, let's talk about the mitochondria and how they relate to chronic disease. My understanding is a lot of chronic diseases, we always talk about oxidative damage and inflammation, but I think we can trace a lot of these chronic diseases back to dysfunction inside the mitochondria. It's definitely a part of the aging process. So talk to me about that, its relation to kidney disease and mitochondrial in general, and then we can go down the things that we can use, being peptides, to influence mitochondria and improve mitochondrial health.
Thank you, Fiona. That's a wonderful topic, and let's get stronger with stronger mitochondria.
Yes.
And literally, it's people probably know that when they do exercises, they improve the functional health of their mitochondria. So they get stronger, and their mitochondria get more adaptive, more metabolically flexible. And at the same time, when mitochondria get healthier, people subjectively experience it as a boost of energy and more radiant skin and improvement of health on many levels. And today, when people ask me how to assess their mitochondrial health, conventional medicine doesn't have much. Sometimes indirectly, we can see some dynamic in certain lab parameters, like improvement of creatinine and BUN level when we improve mitochondrial health. But to see directly what we do to mitochondria, it's probably still too early to talk about this. There are scientific biotech companies that do what they call mitochondria omics. And the mitochondria are very complex structures, and they have so many different parameters, like entire body. They have membranes that consist of proteins and lipids. They have different charge on different sides of membrane. They have different layers of membranes. They have what's called transmembrane potential. They have pores in the membranes. They responsible for letting proteins and peptides and nucleic acids to travel through them. They have inner space of mitochondria where even ribosomes exist, like in the rest of the cell, and where the synthesis of protein happens. And mitochondria have their own exosomes, that there's extracellular vehicles that exist inside the exosomes. Just to name a few, I don't want to overload our discussion today with deep knowledge of molecular biology, but Probably a lot of our patients study and interested in learning this and to understand what they do when they use peptides or when they do exosomes or regenerative / cell medicine products. So it's important to understand that mitochondria are extremely complex structures. And to get back to the origin, they probably started emerging inside the complex cells of high organisms about 2 billion years ago, when certain nice bacteria got into symbiotic relations with complex organisms and eventually became part of the cells, helping the cells to produce energy and gradually becoming main centers and power stations that produce main currency, main energy source, that is ATP inside the cells. And as the heritage from the bacteria, they originate from, they have a circular DNA structure that has about 20,000 genes. These genes mostly encode certain proteins that mitochondria need for their own rebuilding, dividing. That's called mitochondrial fission. That we'll talk a little more about later. And there are also there's also genes that code for certain mitochondrial peptides that we'll talk a little later. The mitochondrial peptides that people probably know are MOTS-c, that's coded inside the mitochondrial DNA, and humanin, that is smaller peptide, also coded on the genes in mitochondria, and humanin like small peptides 1, 2, 3, 4, 5, 6 that are also coded inside the mitochondria. Other peptides that have different importance for different conditions, for different mitochondrial functions, but for practical purpose, we'll focus on this few that been more or less clinically researched and utilized in the treatment of different diseases, been in clinical trials. And mitochondria also able to divide and proliferate. That's called mitochondrial fission. They can also fuse, like a nuclear fusion, and sometimes they need to fuse to stay stronger and to survive cellular stress and to avoid apoptosis. And sometimes they divide, that's called fission, to increase the amount, to adapt to certain conditions. All these different functions and processes regulated by different peptides and different genes. There is also, over the 2 billion years of evolution, mitochondria became much more interactive with other cellular structures. They interact with nuclear, that means inside the cell nucleic acids, with major DNA spirals that code for major genes. And actually mitochondria interact with intranuclear genes by, for example, peptide MOTS-c, that is reverse signal peptide that can travel from the mitochondria to nucleus and to affect function and expression of main genes, and to help to adapt, to improve cell survival, particularly in times of stressors, low glucose levels, so overload with reactive oxygen species. This amazing peptide able to improve mitochondrial function as well as hit targets inside the nucleus and to affect major life vital functions and regulating genes inside the nucleus. That's one application. Mitochondria also interact very significantly with other organelles or structures inside the cell. For example, complex Golgi that has a function of packing and repacking proteins that translated by other structures. And actually, the humanin was discovered by Japanese researcher Hashimoto years ago, where they were studying abnormal protein formation in Golgi complex in Alzheimer's disease, and found that peptide was vital for certain interactions there. So they started studying humanin from this point of view, and then found the presence of this peptide in many organs and tissues, and we're finding more and more functions and applications for this peptide. So it's also very interesting. And there are peptides that not actually coded for by mitochondrial genes, but they are either synthetic or produced by some other cellular functions. For example, SS31, that has some another complex name that's hard for me to remember. It's a researcher's name.
Or something, isn't it? Elampatrine or something like that.
Some two German names of researchers who developed it.
Okay.
In addition to the name you mentioned, that it's kind of generic
Drug name, yeah.
Generic drug name, yeah. This peptide is one of cell penetrating peptides, peptide that able to penetrate cell membranes and get into the cell. But a smaller group of cell penetrating peptides are also mitochondria penetrating peptides. So SS31 is able to penetrate through membrane of mitochondria, get inside mitochondria, and affect very intimate process of phosphorylation. So the process of electron chain transfer that's very basic for ATP production, very basic for synthesis of energy inside the mitochondria. Also, it affects lipid oxidation and some other process. We'll talk about this later. But for now, it's important to understand that some of mitochondrial peptides we're going to use, we're using in the practice are coded and in the genes of mitochondria itself. And SS31 is not original mitochondrial peptide, but it by means of penetrating cell membrane and penetrating mitochondrial membrane, it provides vital function and action inside the mitochondria.
Okay.
So, and there are peptides that are also coded inside mitochondria. They are small peptides, short chain, humanin-like small peptides, and their number is most studied was HLSP 1, 2, 3, 4, 5, 6. Most studied are 2 and 3, and we'll talk about them as well.
Okay, fascinating. You know, I know most of this, I don't know much about the human and small peptides. So before we go on, I want to know so people might be thinking, what are the kinds of things that damage the mitochondria? How do mitochondria become damaged, destabilized, you know, in kidney disease? What are those sort of things that might trigger mitochondria to no longer work the way that they should, and hence therefore go forth and create or contribute to disease and aging?
Thank you. So usual suspects. First one is reactive oxygen species, oxidation. And it's very interesting that mitochondria themselves produce some oxidation, but it's mild, and actually appropriate amount of oxidation is necessary to stimulate many cellular processes and for body to function normally. But when it's more than we need, there is overload with oxidative species, and for chronic kidney disease, particularly important, and other reactive species are reactive nitrogen species. So, for example, uremic stress overwhelms mitochondria. All these endotoxins that people can get from failing kidney function, failing hepatic function, liver function, and also from excessive manifestation of senescent phenotype, SASP. They all lead to overwhelming mitochondria. And probably people know that there is new science now in the toxicology and the toxins produced by cells. And there is even intracellular toxins that produced by abnormal function, for example, by excessive lipid oxidation is okay, but lipid peroxidation, particularly when it's excessive, overwhelms kidney. In chronic kidney disease, it's particularly dangerous process, and many variety of kidney diseases always related to excessive lipid peroxidation inside the kidney cells. And while I'm talking about this, mitochondria, so there are a variety of different kidney cells. For example, proximal tubular cells that are extremely important for reabsorption of very valuable nutrients. There are, of course, podocytes with their legs. There are nephrons and endothelial cells and mesangial cells. They have a very different functions. So all these cells can get overloaded by hyper or hyperfunctioning in one of few processes they are responsible for. For example, mesangial cells can be particularly sensitive to inflammation and to interleukins, abnormal cytokines. They also have intercellular signaling that affects mitochondria, and endothelial cells particularly sensitive to oxidative damage and to circulating toxins, just to name a few. And of course, external toxins like alcohol, tobacco, very important, and viruses. Viruses are very smart organisms. Most of them have cell-penetrating peptides they use. For example, now in science and biotech, people use peptides from HIV virus that is a vehicle for other good things to get inside the cells. But unfortunately, viruses have cell-penetrating peptides, and they, of course, interfere with nucleic acids and with intimate processes. And as I mentioned, mitochondria interact not only with nucleic internuclear DNA, but also they have very direct connections, even direct contact with complex Golgi, with endoplasmic reticulum that very involved in lipid oxidation and metabolism process. And all this disruption affect metabolic flexibility inside the cell, particularly inside the mitochondria, and affect the mitochondria. So as we just discussed, infectious diseases, chronic inflammation, viral infections, toxic products from failing organs, hormonal disbalance, they all responsible for mitochondrial damage and attrition. And what's interesting also, they are very intertwined with telomere health. It's a lot of energy produced by the cell, huge amount of energy consumed to restore telomere lengths. At the same time, it was noted and described in articles that shortening telomeres somehow causes mitochondrial attrition as well.
Oh, wow. I did not know that. Okay, interesting. So it all goes together, and it's all the stuff we talk about all the time of inflammation, oxidative stress, all the stuff we know. And for people, that don't know, overloaded diet, lifestyle, toxins, pollution, all of those things then filter down into everything that Dr. Grinberg's talking about. So you wanted to add?
I will just add a couple of things. And overload with senescent cells, of course, and autoimmune conditions, they all affect mitochondria inside the cells. My apology for interrupting you, Fiona.
No, not at all. Please always interrupt me. It's all good. So, okay, so that gives us why mitochondria might be damaged. When are you thinking, so if you've got a patient in front of you, when do you think, okay, I need to intervene and do something about the mitochondrial health? Is it every patient with a chronic disease, knowing that mitochondrial health might be affected and it's hard to test that sort of stuff? Or are there certain lab works or certain symptoms or certain conditions where you would favor mitochondrial intervention over other diseases?
Every human being. In today's world, every human being needs improvement of mitochondrial function, at least for prophylaxis and to support and to upgrade the energy production.
That's a nice, simple answer. So are you ready to dive into these different mitochondrial peptides, or is there anything else you want to add before we get into each of the individual ones?
Yes, definitely. So in my practice, I see great effect combining mitochondrial peptides for any protocols, whether they be for just longevity, for athletic performance, for endocrine/sexual enhancements, for aesthetics, for improvement of effects of other peptides, for recovery and regeneration, for cognitive enhancement, for ophthalmic health. When we deal with oncology, there are certain considerations because cancer cells love to steal mitochondria from healthy cells, and you don't want to help them to do it. So that's a different story. But in most other conditions, we see very good effects of combining mitochondrial peptides. For example, hot topic GLP and weight loss. I see much better results when I combine mitochondrial peptides with the use of GLP. People feel great, they lose weight more efficiently, and they able not only not to lose lean mass when they use GLP, but they also able, if they of course exercise and consume enough protein and have good nutrition, to gain lean muscle mass and to efficiently improve their body composition. Of course, there are other peptides that could be involved, some growth hormone related peptides and peptides that target gaining muscle mass, but definitely mitochondrial peptides are extremely important there. Cognitive enhancement and declining memory, for example, combining them with C-Lung, C-Max, P22, 28 gives much better results. People feel sharper and younger and stronger and have very nice off-site effects of improving their muscles, not only feeling better cognitively, but feeling better overall physiological improvement and rejuvenating effect. Targeting telomere health, of course, I combine them when people take epithalone and other peptides that help them to get this. People with different fibrotic conditions, liver fibrosis, kidney fibrosis, and lung fibrosis. People should understand that to enhance effects of other peptides, for example, to deal with fibrosis, you need to modify function of fibroblasts. But these fibroblasts need energy to get reprogrammed. And where are they going to get energy from? Because when someone has fibrosis, they already probably compromised because of endotoxin, be it liver fibrosis, that accumulation of toxins, or kidney fibrosis, or lung fibrosis. All these conditions cause either excessive reactive oxygen species and nitrogen species, or some other endotoxins, and cells need help with their mitochondrial health and energy production to be able to respond to other peptides that target other genes, and expression of which will help to reduce excessive extracellular matrix formation. Then if you want to deal with senescence and want to activate NK cells against senescence, how the NK cells need a lot of energy to travel everywhere to search and eliminate either senescent or mutating cells. And where they're going to get energy for this travel? You need to fuel your car to be for long distance travel, to put it in simple words. And the same for other immune cells. If you want to invigorate your cytotoxic lymphocytes for fighting cancer, if you want to invigorate antibodies production for fighting chronic Lyme disease or something else, everywhere you need energy and for a number of cellular processes, right? So, and of course, for different kidney condition, there is no question all these peptides, they help so many functions. First, they help kidney cells to survive. They help to stop apoptosis. That's extremely important. So at some point, people should stop losing kidney cells because of these conditions, at least to stay at the level where they were. Then next stage would be talking about help. Very promising area that I also love and participate in research, cell medicine. And for stem cells production, you need to give energy to your bone marrow. If you think about your own autologous stem cells, and bone marrow is also suppressed by all these toxins, uremic toxins, and lack of erythropoietin related to chronic kidney disease. So at least first you need to help it externally. So all these mitochondrial peptides will help bone marrow to produce more stem cells that hopefully hypothetically get to kidney and at least fix some damage. And if we get to more complex external interventions with more specific, highly differentiated kidney progenitor cells, specific exosomes, we still need more energy for cells to give them nice reception and homing for these stem cells and give them a chance to better differentiate and to do their work. So it's also extremely important.
No, that's great. That makes sense. So
diabetes is so few major conditions that lead to kidney failure: diabetes, hypertension. So for diabetes, all mitochondrial peptides are directly related to insulin sensitivity. They all improve insulin sensitivity. That is extremely important, and it immediately reduces glycalization of proteins and immediately reduces kidney damage. That the glycalization of proteins is a major harming factor for the kidney. And all these peptides improving this function. They improve metabolic flexibility. Some SS31 improves also lipid metabolism process and reduces lipid peroxidation inside the kidney. So it's extremely important for cell repair and survival. And kidney is the most sensitive and vulnerable organ, needs it first. So,
which why it gets so damaged, makes sense. So walk me through each of these big peptides. We've got MOTS-c, humanin, SS31, and then the MOTS-c, the humanin-like small peptides. Which one do you want to start with? And let's discuss the differences, dosages, and when you would use one over the other, or are you combining them, sort of thing? So
it's interesting working with people suffering from different forms of kidney conditions. I see different response to different peptides. So I'm very careful, and I'm starting with humanin, because humanin has the highest potential to stop cells on their said way to the apoptosis. Apoptosis is death of the cells, and humanin is the peptide that, along with all other benefits with other peptides, like improving insulin sensitivity and repairing cells, it's very vital to just stop pathological process. And some research shows that humanin is also very detoxifying peptide, and humanin also is very good for improving neurons' health. It's also very important to consider, and many people suffering from chronic kidney disease don't realize that slowly, gradually, they have cognitive decline, and because it happens gradually and it's not so abrupt, when they get, say, treatment with humanin, they start feeling better cognitively as well, and it's a very important factor. When people feel better cognitively, their mood improves. It definitely contributes to improvement of overall health, and that's why in my protocols, humanin, talking about mitochondrial peptides, humanin is an entry level, and then I add peptide SS31. It's again, I'm not talking about amounts, micrograms, milligrams, because it's extremely individual. In fact, I see some people sensitive to SS31, and when they get this peptide, they have flank pain, they feel something upset their kidney, but obviously it's the amount is too high. I recommend people to start with very low dose, because when obviously there is some level of pathological homeostasis, body kidney cells adapt in some maybe pathological way to the level of functioning they have with years of chronic disease, and you can't affect mitochondria too fast and too aggressively.
It's interesting, because if you go onto all these biohacking pages and things like that, the dosages of SS31 are diabolical. Like, people are dosing, I mean, I'm seeing general standards of dosing right up at 40 milligrams a day, which generally makes that peptide unaffordable for people, because you're injecting a 10 milligram vial, 4 vials a day, or the 50 milligrams that some places offer, which isn't much, every day. Just to get a 10-day course, you're looking at about $2,000 to $4,000. So interesting to hear that you can use it in those lower doses and generate an effect.
Yes, and that trend to use these high amounts of peptide SS31 comes from big pharma. there were trials in big pharma. It was used in high amounts, and but big pharma, when something is developed as a drug, has different approach, and we in a kind of holistic medicine have different approach. We want the system to be able to gradually switch to a little higher level of epigenetic functioning, and to see how it adapts to this higher level, and to let other axes, because kidney are not alone. When chronic kidney disease, it's kidney liver axis, kidney thymus axis, kidney brain axis, kidney heart axis, and everything interconnected, and everything should adapt and adjust to little different level of functioning, and then you can proceed. And this way, usually big pharma creates medications that help to suppress disease, but we're looking for root cause treatment and gradual improvement, and hopefully total cure for conditions. It is also possible. And this way we constantly need to be very specific, customize, individualize the amounts. I don't see any fall in starting very micro doses of SS31 and achieving effect gradually versus overwhelming the system. And people should realize that mitochondria, if they too active, they can produce a lot of reactive oxygen species. And the microcellular, intracellular environment, particularly in damaged, compromised kidney cells, may not like it.
Yes, so you can overstimulate it with these great big doses. And I know the bulk of biohackers and things online are talking to healthy people. We're obviously talking to a very different population, but it's interesting to hear you say that, because I had read some things where people just weren't getting effects at lower dose. But of course, as you say, we're looking for a completely different, we're looking at supporting the body to be able to do it itself versus forcing it into a reaction that it actually may not have energy for, despite you giving it a mitochondrial peptide. So that's super interesting. Okay, anything else about SS31?
Before I proceed with SS31, general recommendation based on my experience and observation, please be very patient with peptides, and start with low dosages, and be very observant and what happens to your body, because peptides are very precise tools, but unfortunately in our conventional medicine there are a very limited number of tests so far, clinical tests that can pick up very subtle variations of what happens inside the cells. For example, talking about mitochondria, mitochondrial omics is very beginning stage even for biotech industry, leave alone like everyday medical offices. And that's why it's extremely important to be very observant and to be very careful. And again, be very patient. And again, depending on each specific, people know there are so many different nephropathies and different conditions in the kidney, and you need to properly combine them. If people just use SS31 and say have some autoimmune related neuropathy, they may give SS31 is targeting not only kidney, it has targets in the brain and most of the cells and tissues of your body. And if it activates energy production and mitochondria of cytotoxic lymphocytes, maybe they attack kidney even more, some other parts of the immune system. What's get activated first? Then you need to think how to combine it with peptides that regulate the immune system not to attack you. And it's extremely important. And that's why I'm saying use it in very small amounts and smartly in combination with peptides that would mitigate and prevent flare-up of a main condition and main pathogenic origin and mechanism that underlies any specific kidney disorder that people have. So it's extremely, so it's the word mitochondria is not panacea. Just improving mitochondrial health doesn't mean it automatically improves everything. It needs to be taken in very thoughtful context of thinking about all organs and tissues involved in the process. And having chronic kidney disease also with the time being compromises all other organs, and they're not able to maintain homeostasis as they supposed to, and just affecting kidney, mitochondria never happens, whether with MOTS-c or humanin or SS31. It affects mitochondria in all cells, and it affects some other function in many other cells. And be considerate of this, please.
Yeah, no, it's great advice, Dr. Grinberg. I'm really glad you addressed that, because it's the biggest thing I see. And you and I talk about all the time, about even just when it comes to GLP-1s, and then they get a bad reputation because people are getting delayed gastric emptying and all their side effects. And you and I had spoken off camera, I think, and we did a podcast on it, just about, I don't get any problems when we microdose and start really low with patients, and we go for obviously dietary intervention and then slow weight loss, and you get these much better long-term effects when they're dosed correctly, not at these great big whopping doses that especially GLP-1s, that we do see issues. So it's interesting to see that it's exactly the same with the mitochondrial peptides. Okay, keep going.
With all peptides, so I like to combine them with epithalone, because at least understanding that mitochondrial health and telomere health are intertwined, it's very important. And epithalone mitigates a lot of other conditions, and obviously it mitigates unwanted effects of mitochondrial peptides to some degree. Again, it's empirical observation. I have to say that the peptides research is extremely complex, because they're more pleiotropic, that means affecting so many organs and systems, than any small molecular drug that big pharma is using. I think that's a major obstacle for switching from small molecular drugs to total peptide pharmacology. Eventually it will happen. Probably AI and higher throughput driven by AI will help to see more things, but so far it's very difficult, and we're still on empirical path. And for patients who experiment and do it, it's very important to take everything into consideration. And then for people struggling with chronic kidney disease, it's important to mitigate unwanted immune system activation. For this, I use thymolene. It's a nice, mild, nephroprotective and immunoregulating peptide that is not so active as thymosin alpha-1 or thymosin beta-4. But it's more targeting T regulatory functions that is good.
Yeah, it's probably one of my favorite. That and Villon are my two favorite. Actually, after doing work with you, they're my two favorite thymus-derived peptides, and you can use them in really low doses and get really amazing results. So yeah, I'm a big fan of those two as well. Okay, anything else about SS31, or did you want to talk about? I really want to hear about MOTS-c, but I really do want to dive into the humanin-like small peptides, because that's something I've not heard anyone else talk about.
So yes, let's focus more on clinical application than on scientific use here. Just about SS31, it's also good for cardiac cells. It mitigates damage after myocardial infarction, and it's good for neurons. It mitigates damage after strokes, but as well as humanin and MOTS-c, but they all affect different functions of mitochondria. Obviously, it's important to approach mitochondria in multifaceted way, and you achieve progress in the conditions where ischemic damage the tissue, and it's major cardiovascular or cerebrovascular events. And of course, people know that cardiovascular events affect kidney. Frequently, low cardiac output translates into hypoxic damage to kidney and acute kidney injury. But again, good news is even after acute kidney injury, mitochondrial peptides are there to help people to recover and restore kidney function. That's very important to understand. And there are more and more research on SS31 for cognitive impairments. So pleiotropic functions are everywhere. It's a vital part of chronic kidney disease treatment. But again, I ask people to be very cautious and consider all possible implications of using certain peptide.
Makes sense. Okay.
And next would be humanin. Humanin, as I mentioned, is a very nice peptide that stops cells on the way to apoptosis. That means cellular death. It's very important to stop any pathological process to avoid losing more cells, whether in the kidney or in the brain. And this peptide, but again, I recommend people to start it with low amounts, low doses, and gradually increase it, at least to help system to adapt to it and see how they tolerate it. Because again, extremely rare, some peptides are immunogenic, and it also may happen. And there is no punishment for go with low amounts and slowly.
Correct,
And
yes.
and again, people have to be patient. Some people stop using peptides because they say they see no effect. And there is effect, and some effects inside the cells are not such easily sensible effects. It takes time, and I see the best results when people have long-term peptide protocols, that protocol flawlessly changes, transforms to another protocol where we're able to target all different systems in a mutually supporting way, and considering all physiological implications. And gradually everyone sees good result, and people usually resolve to using stem cells or exosomes. Using them, they may feel immediately some burst of energy. But again, I recommend when people use exosomes or stem cells, combine them with peptides to prime the systems to be able to accept them and to get the best from using these products. And it's and again, some exosomes may contain mitochondrial peptides in them. Some exosomes may contain whole mitochondria, and the factors that exosomes contain. Exosomes is a very broad science. It's a big topic, and probably exosomes are as good as stem cells or cells they derive from. It all should be taken into consideration, but their characterization and validation is even more difficult than peptides, because exosomes are very complex structure. They carry hundreds of peptides, growth factors, nucleic acids. It's extremely expensive to do mass spectrometry or electron microscopy and to characterize them. And so my point is that people may have more immediate results with these treatments, but not necessarily no longer lasting than treatment with prolonged and very targeted courses of peptide therapy.
Well, that's an interesting point. Okay. So tell me more about the humanin-like small peptides. That's not something I know a lot about, or that people have spoken a lot about, especially numbers 2 and 3.
Humanin-like small peptides are also coded in mitochondrial DNA, short sequences. And it's interesting, they found even in the brain, they activate some nucleus in hypothalamus that is responsible for satiety, for glucose metabolism. So they may help to reduce weight and to regulate appetite and feeding. But at the same time, they are very like human-like. They also participate in biogenesis, in processes of mitochondrial survival, and in rebuilding mitochondria. And they also prevent other cells from getting into apoptosis, or to stopping cellular division. That's also very important. And they have some variations from 1 to 6, but in general, they can be very useful and very miraculous, and all of them significantly improve insulin sensitivity. That is extremely important for kidney health, for metabolic health, for everything, and for healthy people. It's as even healthy people who have so-called healthy aging, they still have loss of insulin sensitivity, and that's we don't want this to happen. So obviously, humanin-like small peptides are very important in aging, preventing aging, and biogenesis, and what's called cellular fitness processes. It's extremely important.
Very interesting. Okay. And those Shimano, like, are you dosing sort of very similarly, microdosing and building up with those? Are they sort of as biologically active as the bigger, well-known mitochondrial like peptides that we're talking about?
Yes. This is, I would say, it's generally good advice for any peptides. Start with microdosing.
Okay.
There is no, it's significant risk mitigation and probably also overall improvement of desirable effect. And as we mentioned in previous podcasts, sometimes I recommend people to do very low doses, but few times a day, because most of these peptides have extremely short half-life, and to tackle the targeted genes and to improve the expression, sometimes I see much better results with microdosing, but may used more frequently. And obviously, and then I see we achieve some desirable effect, at least subjectively. I can reduce the frequency. I can try to increase the micrograms that people get. So it's,
yeah, I've been doing that with patients after we spoke about it, and I'm seeing good results with frequent microdosing and then being able to reduce it back. So
I'm glad to hear that. Yeah.
Yeah, definitely. Good. Especially in things like I actually have been doing it with the most alpha 1 in my very sensitive patients, where I'm worried we might get immune reactivation of latent viral sort of loads. And so, but they're a bit autoimmune. I've found really good results microdosing TA1 in a higher frequency and then dropping off quite quickly. So it's been great. So thank you for that advice.
You're very welcome. And there is very interesting thing also that people should consider. Actually, we did some research. We were with the omics company. I was harvesting blood samples from my patients, and prospectively we were incubating them with peptides, with many different peptides and their combinations. And it's very interesting. From person to person, there is activation of different genes. Obviously, it depends on complexities of genome, other operating systems, that one groups of genes controls other genes expression. But also it's another very interesting issue that we just started diving into or digging into was dose dependency. And for peptides, so far preliminary results, we see that for peptides, it's not your regular PK/PD, pharmacokinetics, pharmacodynamics that we see in regular small molecular drugs. It's more like individual specifics of genome that is accounts for dose dependency for peptides. So in different dosages, it may affect different genes, to put it in simple words. Effect may be different.
Fascinating. I find that fascinating. That's where things like Neo7, which we did a podcast on before with their AI and mapping out. So if anyone that doesn't know, Dr. Grinberg and the team from Neo7 and I did a podcast. It was very specific about they map out your genome, run it through their AI system that they've built to actually give you a protocol about exactly which peptides to use that will turn on and off certain epigenetic expressions. So it is such a new field, and we really don't know everything about it yet. So yeah, super interesting.
That's a vast universe of information signaling, and it's like internet inside the body.
Exactly. And we are tweaking around with things that we're not sure.
Yes, yeah. Signaling with peptides. So, and then MOTS-c, actually I have to add that all these mitochondrial peptides also good, some of them in one or other way interfere with pro-inflammatory signaling and inflammation pathways. And the particular MOTS-c is involved in activating an AMPK and ACAR pathway. That's very important inflammatory pathway. And in addition to its other very important functions, MOTS-c, of course, also affects insulin sensitivity. But one of hallmarks, if I can use this word, for MOTS-c is helping mitochondria with autophagy, so eating itself. So it's important process. It's like in a huge scale. Entire body gets rid of senescent cells in the process called senolysis. Here in mitochondria is like a copy of the big organism on a smaller scale with all these major processes inside it. And when part of mitochondria becomes old, it's good when it's able to dissolve or eat it and give room to younger structures of mitochondria to replace it. Mitochondria has membranes, layers of membranes. They have proteins and lipids and pores, and also mitochondria participate in intracellular calcium metabolism. Intracellular calcium metabolism very important. People should understand. It's very there is very thin age when there is excessive calcium signaling inside the cells. They move toward apoptosis. It kills them, and it frequently happens in kidney cells when people have CKD, and frequently CKD has correlations with the PTH level variations, and this is parathyroid hormone that also involved in calcium metabolism on a larger scale, but it also happens on smaller scale inside the cells. And all mitochondrial peptides, particularly MOTS-c, also involved in intracellular calcium signaling. It's also very important. And another thing is MOTS-c has extremely important function. It's a messenger between mitochondria and nucleus, and it's basically diplomat, messenger. It's a communication between all bacteria and eukaryotic cells DNA, and does amazing things. At times of stress, it moves inside the nucleus, attaches to DNA, and helps cell to protect against the very low levels of glucose or from reactive oxygen species, and it activates actually triggers activation of genes that help cell to survive and to adjust. And it happens both ways. And also some peptides are coded in the nuclear DNA, and they travel to mitochondria to save it when it's necessary. It's amazing when you study it and see it. You see amazing level of intelligence on the micro scale in the intracellular process, how these organelles interact, how mitochondria, for example, Golgi complex at the times of stress attaches itself to mitochondria and hibernates on mitochondria surface. That's very interesting.
Does it?
Yeah.
Wow. Is that like for an energy kind of thing? Like that's a preservation of its function?
Even more complex. There are some proteins expressed by both of them, and they participate in even more subtle processes inside the cell. So some of these proteins in healthy body involved in anti-cancer process, and when cells mutate and move toward mutagenic or turn into cancer cells, there is expression of certain proteins that can make mitochondria very vicious and not useful. And but it's an entire area of cell biology, molecular biology. It's extremely interesting. But these mitochondrial peptides we're talking about, they studied more than others. But again, there is a lot of dark matter. But but they have very good effects. They definitely help people to survive, and in combination with different peptides we use for different conditions, they help glaucoma, they have early stages of dementia, they help muscular dystrophies, they help hormonal disorders, and they definitely help in diabetes and in so many other conditions. And for people with CKD, definitely I would use all three of these peptides, but gradually And eventually, when people find the safe and working dosages and frequencies for them, they can be combined in one protocol because they all affect different structures and functions in mitochondria on a smaller scale and a larger physiological scale and different organs. They definitely smarter use. They can be extremely useful for people struggling with chronic kidney disease. And again, in combination with many other peptides that we discussed before, with GLP-1 peptides, with peptides that target fibrosis, with peptides that target endothelial lining. For example, even a well-known and beloved BPC-157 improves endothelial function, improves response to nitric oxide. That's very important for kidney. And when kidney cells have better energy production, they will be more responsive even to BPC-157. And you can see good results combining just BPC-157 and say cumanin or SS31. I see people, I'm very careful was starting peptides, and sometimes I start BPC-157 in combination with humanin. I see very good results. And people want to improve collagen production, elastin production. Combination of mitochondrial peptide and GHK is also very good. Again, but there are so many peptides. It's beyond what we can discuss now, but smart use of combination of peptides and understanding the basic that for any peptide that targets something, a very important thing for it to work well is have enough energy and use mitochondrial peptides. It's, I think, most useful advice people can get from this discussion.
No, it's been a fantastic discussion. It's definitely highlighted a few things for me that I will make some changes in clinical practice with how I work. So it's been great. Is there anything else you want to say before we finish up?
Please, any questions, I will be happy to answer.
Amazing. So I think, well, I don't have any questions. I think you've answered most of it. I'll just sum up and tell me if I've heard anything incorrectly, but it sounds to me like Humanin is a really nice starting point for people that want to maybe try mitochondrial peptide and maybe try stacking that with BPC, two really nice ones together. Always start low and go up. You don't need to be doing these great big whopping doses, especially SS31 is the one that's got a lot of research next to it about big doses. So start small. And I always remind my patients healing from a chronic disease is a marathon, not a sprint. So we want to find the lowest therapeutic dose. Sometimes with peptides, you might start on a lower dose, but dose more regularly during the day versus a one dose in the morning or at night. So it might be like, 2 to 3 times, depending on the half-life of that. Epitalon is also a really nice combination with these because to increase the length of telomeres, you're going to need to have mitochondrial peptides. And what I hear is mitochondrial peptides and energy. By using them, you're giving the body in the mitochondria more energy to heal. So they sort of become part of a protocol in there somewhere. Again, as I mentioned, Humanin being a nice one, but SS31, MOTS-c, they can all be stacked together if you need to generate more energy into the client or the patient to help them heal. They also combine very well with GLP-1s, especially if you've got, say, diabetes or obesity and things like that driving chronic kidney disease. You might think about microdosing GLP-1s.
Even without these conditions, even without higher blood sugar, microdosing of GLP, particularly tirzepatide, combining it with low dose of mitochondrial peptide may be a very good idea. And because GLP-1, as we discussed in previous podcasts, have so many receptors that respond to them in the endothelial tissue, in cardiomyocytes, central nervous system. They have so many positive effects that alleviate kidney conditions even without direct effect on weight loss. So combining them with mitochondrial peptide will again will be very potentiating and augmenting for the effect.
Yeah, and we've spoken before about I can't remember if we said it in our GLP-1, but we now know, and GLP-1s will start to be repurposed because they specifically help reverse fibrosis inside the kidneys, that we now know they work with Alzheimer's and all those sort of things. So this is the other thing that you mentioned too before that I want to reiterate is that we don't know a specific we know peptides will work in certain areas, but it is very individual depending on your epigenetic expression of how a peptide will go in and then change epigenetic expression, and dosages will change that. And then just your genome will change that. So it is very individualized medicine, which I would take back to saying, I always think with peptides, and I do tend to experiment on myself a little bit, but I have you to bounce ideas off. I think everybody should be working with a physician that is well trained in peptides. And there's not, and to be fair, I don't think there are a lot of good physicians around that really understand peptides. I'm, as like you, very lucky to be part of Pep Docs. And so I know all the ones in the US that are doing this and working this way. But peptide training in general is these big doses, one dose, this works for people versus what we're talking about. And there will be coming more and more practitioners that are well versed in this stuff, but because it's new science, there aren't a lot of practitioners that are really trained on the nuance about this stuff and how to do it. So I think anyone that, especially with a chronic disease, because the standard dosing given by all your amazing biohackers, whether it be the Human Upgrade Project of Dave Asprey or Ben Grenfield, they're talking about healthy people that don't have chronic disease. It's very different when you're using peptides, and definitely been my experience, like TA1 in some patients and a low dose will send them sideways because you reactivate a really latent Epstein-Barr virus. I've had that happen twice now. Whereas you would look at that and say that shouldn't happen. So I think if you've got a chronic disease like chronic kidney disease and you want to try peptides because you've been doing everything else and you're looking for that extra bit, work with a very well qualified practitioner that understands the nuances of these things, like Dr. Grinberg, because I think it's a very hard thing unless you've got medical training to know how to nuance these sort of things if you don't have that natural intuition or understanding of how the body works. I think is my big thing, because what I definitely see in this field is just lots of people trying and experimenting on themselves in big doses. And if you're healthy, you can maybe get away with that. If you're not healthy with a chronic disease, I don't think you can. So that would be my take on that. I don't know if you have anything different on that.
Few things I would like to add. So one on the some precautions. So I always recommend people before they start peptide protocols some extensive checks for cancer. There are conventional medicine available tests for cancer markers, and there are additional tests like Grail Gallery Company that do some determining relatively early cancer detection signals. So it would be good, and considering history of cancer or risk factors for cancer, it's very important when you want to activate your mitochondria. That's very important. Second thing is complementary use of supplements. There are few supplements that also may be complementary to mitochondrial peptides. It's a MitoPure that helps mitochondrial autophagy, and there is amino acids called spermidine that also important for mitochondria. And again, I wouldn't go too high with their dosages. And there is a supplement called PQQ, but this one usually goes in capsules 20 milligrams, and there is the nephrological research that it can be damaging for kidney at this amount. So if people want to use it, I don't recommend more than 5 milligrams a day.
Yeah, it's the one reason I haven't spoken about it on a podcast, because I haven't seen low doses in capsules yet. So that yeah, it's
unfortunately, yeah. And I also see good response when I combine mitochondrial peptide with good reliable cordyceps, and yes, and for some kidney condition, rhodiola and cylindronide, that is an active ingredient, are very helpful because it's natural mild stimulation of adrenal cortex is good, because for some particular autoimmune process-based kidney conditions, it's not bad to slightly stimulate adrenal cortex, and to mitigate autoimmunity and inflammation by doing this. So, and these supplements can be combined with mitochondrial peptides as well.
Yeah, and again, I just take that back to please work with a qualified practitioner to get all this stuff right, because there are some nuances. And peptides for a lot of people, especially, at the moment, are quite expensive. So if you're going to use them, you want to use them precisely, and you want to make sure that you're getting the most out of them, because otherwise they can become very big injections and very expensive without you getting the effects that you want. So again, I think working with a qualified practitioner helps.
Well, then microdosing is a win-win situation. People save money and save their health.
I totally agree with you. It's my big thing now. Dr. Grinberg, thank you as always for sharing your wisdom and your knowledge. If anyone wants to get hold of Dr. Grinberg, you can find him at infinityepigenetics.com. I will put his website link in the show notes there. He's got a contact him page at the bottom there, and he's got his email address on that page. So if you want to have a consult with him, he works with people all over the world. Definitely, if I get a tricky patient, I'm always sending them across to Dr. Grinberg, or we're jumping on a call together. And if you want to know more about what we do, head to www.kidneycoach.com. We've got a new website launching in the next couple of weeks, so look out for that. But our current website's up there. Please also head to our Facebook page and Instagram. We are posting information there all the time, and we write articles. So there's some really good articles up on our website. And remember to hit subscribe and like. That way you'll get notified anytime we put up more content. If there are any particular areas that you would like me to invite Dr. Grinberg back to talk about, please put them in the comments section. He is very accommodating when it comes to this sort of stuff. So please let us know what you would like us to talk about. Dr. Grinberg, thank you again for your wisdom and your time and your knowledge, and for being such a level-headed, reasonable brain in this space. It's really, I feel very lucky to have you in there. And I know everyone in Pep Docs is always very grateful when you come in and chat to us and run training as well. So thank you. And everybody listening, thank you for being part of our community. Look after yourselves, and remember, healing is a marathon, not a sprint. And if you're going to use peptides, please make sure you work with a qualified practitioner. It is much trickier than the biohackers let you know. Thanks again.
Thank you very much, Fiona.
Thanks. Bye.